Okay, students, good morning, all of you. Our next topic discussion on blood groups and their importance. See, yesterday in the introduction part, we have seen that its continuation. Now we will have a look on this. So, in the year 1900, Carl Land Steiner, Carl Land Steiner. So, he discovered different types of blood groups. Before discovered and finalized the blood groups, he conducted one experiments. He collected blood samples from different group peoples. Blood samples from different peoples. So he took one test tube, he took one test tube, he took one test tube like this way. He collected blood samples from different peoples. So those blood samples he took into the test tubes. Randomly, without knowing those people's blood groups, he mixed. This blood group is mixed with 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 this blood group is with this blood group is with this. Like that, randomly he mixed with each other. Okay, so in his experiment, like this, different blood samples are collected and mixed with each other in the test tube and observe the result. So in this one, blood. Clot, 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 clot. This clumping of blood cells is called is called agglutination. Agglutination, nothing but clot. Clumping or clot, coagulation, all the synonyms. Okay, so this clumping of blood cells is called agglutination. So this clumping is occurred in test tubes. Therefore, nothing dangerous to anybody. If this happens in the blood vessels of a person, if this clumping or clot occurs in the blood vessels, then the blood flow stops in the blood vessels. So that condition leads to death of a person who received the blood from another person without knowing specific blood groups. Okay, so this is what he conducted first. Okay, so after this, he gave the name fourth blood group A. Before this, first he discovered AB blood group, O blood group, B blood group. First he discovered these three blood groups: AB blood group, O blood group, and B blood group. A blood group discovered as fourth blood group. Totally he classified 4 blood groups. He discovered 4 blood groups in the human beings: A blood group, B blood group, AB blood group, and O blood group. Agglutination occurs if the blood samples are not matched. Agglutination is seen if same blood group is not mixed with each other. If blood samples of different people are same, then agglutination is not occurs. That is what he noticed. So in this experiment he conducted like that. Next, from particular A blood group, from A blood group person he took the blood, and from another A person blood group he took the blood and he kept in the test tube. He could not observe any clumping, any agglutination he could not observe. So from this he finalized that as fourth blood group A he discovered. Initially A blood group, AB blood group, O blood group, B blood group. Finally fourth blood group A discovered. First of all, he gave one explanation. Agglutination occurs due to the antigen-antibody reactions on the membrane of the red blood cells. Agglutination, clumping process mainly occurs due to antigen-antibody reactions. So you may be asked that what are antigens? Yes, antigens are blood group antigens. Here, yesterday I said that day before yesterday when I am saying white blood cells, antigens are toxins. When toxins are entered in our body, disease-causing organisms are entered to our body, then our immune system will activate. That is different. Here in our body, antigens already be present. Those are either sugar or proteins. Okay, so those antigens are blood group antigens. So agglutination occurs due to the antigen antibody reactions on the membrane of the red blood cells and in plasma of different blood groups. Okay, mainly this point is very important. Agglutination is mainly occurs due to antigen antibody reactions. Due to antigen antibody reactions of different human beings. Antigens. Antigens for the blood groups. Antigens for the blood groups are located on membrane of red blood cells. Antigens for the blood groups are present on the membrane of the red blood cells. Antibodies for the blood groups are located in antigens are located on the membrane of the red blood cells. Antibodies are located in the plasma. When reaction occurs in between these two, then agglutination occurs. Agglutination of blood occurs due to antigen antibody reactions of different blood group peoples. Different blood group peoples. Antigens for the blood groups are located on the membrane of the red blood cells. Antibodies for the blood groups are located in the plasma of different blood groups. Okay, so that is. An interaction between these two leads to clumping of blood cells. An interaction between these two leads to the clumping of blood cells. Okay, so in human beings, there are two types of antigens are located in the human beings. There are two types of antigens and antibodies in the blood. So antigen A, antigen B. Antibody A, antibody B. There are two types of antigens and antibodies. There are two types of antigens and antibodies are located in the blood groups. So antigen A, antigen B. Antibody A, antibody B. That's it. So here already said that. Now we will see about clear-cut blood groups. So in human beings, there are 4 different types of blood groups have been recognized. Okay, blood group A. The person who have blood group A, those members will have antigen. Antigen A on the membrane of the red blood cells. Antibody B in plasma. The person who have blood group A, those people will have antigen A on the membrane of the red blood cells. Antibody B in plasma. Next blood group. This is blood group. This is serial number. Blood group A. What type of antigens are there? Antigen A on the membrane of the membrane of the red blood cells. Antibody B in plasma. See here, the person who have antibody A, the person who had A blood group, those people will have antigen A on the membrane of the red blood cells. Antibody B in plasma. The persons who have antibody B, blood group B, they will have antigen B on the membrane of red blood cells, antibody A in plasma. The person who have AB blood group, they will have antigen A and antigen B. No antibodies. No antibodies. The person who had O blood group, present. This is the tabular column of blood groups. So there are 4 different types of blood groups have been identified in human beings. The blood group A, antigen A on the membrane of the red blood cells, antibody B in the membrane of the antibody B in plasma. B blood group, antigen B on the membrane of the red blood cells, antibody A in plasma. The person who have AB blood group, they will have antigen A and B on the membrane of the red blood cells. They don't have antibodies. The person who have O blood group, they don't have antigens. They will have A and B in the plasma. Okay, these 4 types of blood groups are found in different human beings. Here, next here, during blood transfusion, blood transfusion means administering blood from one person to another person through the vein is called blood transfusion. During the blood transfusion, matching of the blood is very important. Mismatching blood, if we will transfusion, there is a chances to agglutination. Okay, so during blood transfusion, compatibility of the blood group is important. Compatibility, matching of the blood group is important. Uncompatible blood group, if we will give, unmatching blood group, if we will give, there is a chances to agglutination occurs in another person to whom we are donating the blood. Okay, so in this one, the person who are donating blood to others, those people are called donors. If I will give blood to chemistry sir, I am a donor. If he is receiving blood from me, so he is a recipient. Okay, here one example we will see. Jock and George, both were friends. The Jock and George, both were friends. So Jock and George, both were friends. His blood group is A. His blood group is B. Blood group. Antigens. Antibodies. Jock, A blood group person. Antigens A, antibody B. Jock blood group is B. Antigens B, antibody A is there. Jock and George, both were friends. Jock met with an accident. Immediately he needs blood transfusion. Immediately he required blood. He lost excess amount of blood during accident. Immediately he needs blood. At that moment, some people without knowing, George blood is transfused to Jock. Then what happens? So George blood group is B, antigens B, antibody A. Okay, George blood group B, George blood group is A. He met with an accident, George met with an accident. At that moment, unknowingly, immediately from the George body, blood collected, George donated blood to George. Then what happened? In the George blood vessels, the blood is clumped. Then the George may be fatal, may be death. He may chances to die. So why it has happened? According to blood groups, if you will think, George blood group is B, George blood group is A. In such cases, we must donate blood from A blood group persons only. If the required blood is not there, no problem. O blood group person can donate the blood. If required blood group is not available, there is no time to search. At that moment, O person's blood group we can donate. Why? Okay, everybody knows that. We also knows that in lower classes you might have studied. Same blood group persons only we have to do blood transfusion. Even you knew. Why I am asking? There is one rule is there. Why should be blood transfusion done in between same blood group persons. Why not others? Is anybody can say? I am asking you a question. Why we should donate blood to specific blood group persons only? Why not to others? Can you say? Anybody answer? Can anybody say? No problem. You don't know. Though you studied in lower classes, blood groups you might have studied in 10th, 8th, 9th. Am I correct? In lower classes you might have studied. Am I correct? To avoid clump. Yes, to avoid clump only. Yes, correct only. To avoid clump. There is one rule is there. Say that. Say that. To avoid clump only. No problem. I will say that. See here. Donors antigen, recipient antibody should not be same. Okay. Remember in your life, throughout your life, it would not there in textbook. In textbook, what is there exactly? If I will say, it will finish yesterday only. Textbook, incomplete information, just for reference only. Okay, listen. Donors antigen, recipient antibody should not be similar. In this case, what? Antigen B, antibody B. Donors antigen, recipient antibody should not be similar. If it is similar, clump occurs. Remember, where is it cannot find it is? Donors antigen, recipient antibody should not be similar. If it is similar, clump occurs. So, it should be dissimilar. See, JAK. So, JAK blood group. Okay, see here, JAK blood group, antigen A. So, one more person, antigen A. Antibody B, antibody B. Antibody is same means no problem. Antigen same means no problem. Here our statement what? Donors antigen, recipient antibody should not be similar. Donors antigen B, recipient antibody B, it should not be similar. If we will give blood of same blood group person, donors antigen, recipient antigen, similar. No problem. Donors antibody, recipient antibody same, nothing will happen. Reacting does not take place. So, donors antigen, recipient antibody should not be similar. In this case, what? A person donating to A persons only. Then donors antigen, recipient antigen, AA. Nothing will happen. Donors antigen, recipient antibody different. Donors antigen A, recipient antibody B, dissimilar. Then nothing will happen. That is why in such cases clumping does not take place. Once again, that rule I am saying. Donors antigen, recipient antibody should not be similar. It should be dissimilar. If it is similar, in between these two, reaction happens. In between these two, reaction happens. Interacted with each other. Reacted, antigen antibody reaction occurs. Antigen antibody reaction occurs. Agglutination occurs due to antigen antibody reactions between red blood cells and plasma of human beings. Therefore, the blood is clump. Okay, ma? So one more. Here I am saying, A blood group it is. It is also A blood group. So this person is biology sir. This biology sir giving blood to JAK. No problem, Suzuki Samrai. Why? Antigens. I am donor. Donors antigen. Recipient antibody. Dissimilar. It is A, it is B. Dissimilar. Therefore, clumping does not take place. So clumping does not take place. That's why. So compatible blood group. Compatible means matching blood group. Uncompatible blood group, mismatching blood group should not be transfusion. Okay, ma? Keep it in mind. Okay, okay. A blood group is at that moment biology sir is not available. A blood group is not available. No problem, Suzuki Samurai. The person, if O blood group can be donated. O blood group. O blood group. Okay, here. Can you see, sir? Can you see, sir? Here required. Okay. Can you see, sir? Judge. For judge, we need to give blood. B blood group is not available. No problem. Nothing will happen. Why? So, O blood group is available means O blood group person we can give. So, O person's blood group, no antigens. No antigens, no O blood group. We have given O blood group. O blood group, no antigens. Antibodies A and B. Okay, our statement what? Donor's antigen, recipient antibody should not be same. No antigens only now. Then interaction does not take place. So O person can donate blood to any person. Donor's antigen, recipient antibodies should not be same. So here no antigens only. Then where it can be similar? No antigens. So they can donate blood to anybody. Not only B, even we can donate the blood to anybody. Okay, that's that. So for B blood group person, we must give blood from B person only. For A blood group person, he must take blood from A person only. The respect to A, B blood group is not available for Jack and John. Jack and George, no problem. O blood group can be donated. From O person's blood, that particular blood from O person can be donated to George and Jack because they don't have antigens. Okay, our statement word, for example, O person donated blood to A. No problem. Why? Donors, no antigens. Donors, antigens, recipient antibody should not be similar. But here no antigens only now. Then nothing will happen. Okay, so here one statement you have to remember: donor's antigen and recipient antibody should not be similar. It should be dissimilar. Then clumping process, clumping agglutination does not take place. Okay, that's it. Next, any blood group person, donor's condition, universal. That's why all blood group persons are called universal donor. Universal donor. Okay, that's it. Any person met with an accident. Now, George blood group is AB. George blood group is AB. AB blood group. Antigens A and B. No antibodies. No antibodies. కూర్చోమని సార్ చెప్పండి సార్ మీరు ఇచ్చి పంపించండి 5 minutes క్లాస్ అయిపోతుంది కూర్చోమని సార్ కమ్ సార్ ఓకే మా సి George blood group is AB. Antigens A and B. No antigens are there. No antibodies are present. He can receive blood from any persons. He can receive blood from any persons. Why? See, for example, from A person he can take blood. Why? In his antigens A, antibodies B. Our statement what? Donor's antigen and recipient antibody should not be similar. So donor's antigen A, here antibodies are not there. Therefore, AB person can receive blood from any blood group. Okay, for example, B person. From B person, if we take, so B blood group, antigens B, antibodies A. Donors antigen, recipient antibody should not be similar. Here donors B, no antibodies, so dissimilar. So any person can donate blood from anybody. Or else, from O blood group, no antigens, antibodies A and B are present. So any person, he can take blood from O person also. Why? Donors antigen, recipient antibody should not be similar. Here in this body, what is there? Antigens are there. No antibodies only not there. If you take blood from his, antibodies or antigens are not there. So even from AB person, even O person also can donate blood to the judge. AB blood group. That's why AB blood person, AB blood group person are called universal recipient. He can take blood from A blood group, B blood group, from AB blood group person, O blood group person. AB blood group persons are called universal recipient. Universal recipient. AB blood group person because A and B antigens are there. No antibodies are there. So that he can take blood from any blood group person. He can take blood from any blood group person. Okay, so that's why AB blood group persons are called universal recipient. AB blood group persons are called universal recipient. O blood group persons are called universal donor. Yes. Okay, ma? That's next topic. So many students sent doubts. Let's see. Then O positive BG person, O positive B blood group person take blood from which group, sir? O positive. O positive person can take blood from O positive only, O negative only. Okay, universal recipient. O positive person can take blood from. Same O positive person can take, O negative person can take, no problem. Sir, if O blood group person needs, sir, if O blood group person needs blood and O blood group is not available, then who can donate blood, sir? Yes, if O blood group is not available. O blood group is not available. No problem. AB person. AB blood group person can donate. No problem. AB person blood can donate. So to understand this, here I will draw one tabular column. You follow that. Recipient blood group A, B, AB, and A person can donate blood to A blood group person. No clumping. No clumping. A person if he donate blood to B person. Clumping. Clumping occurs. Why already said donors antigen recipient antibody should not be similar. Next, A person can donate blood to AB blood group. So AB blood group person is universal recipient. AB blood group person is universal recipient. You can take blood from A, B, AB, O. Why? I said already. Donor's antigen, recipient antibody should not be similar. O blood group. O blood group. If A blood group person donate blood to O person, clumping occurs. Why means already said that. A blood group person, A blood group persons, antigens A, antibodies B. O persons antigens, no antigens, antibodies A and B are present. So A person donated blood to O. So donor's antigen, recipient antibody similar. That's why clumping occurs. Okay, donor's antigen, recipient antibody should not be similar. So therefore clumping occurs. Next, B person, if we clump B person, if we donate blood to A person, clumping occurs. Why I already said that? Rule you know very well. Donor's antigen, recipient antibody should not be similar. Next year, B person can donate blood to B person. No clumping. Here you know, B person can donate blood to AB person because AB person is universal recipient. He can take blood from any person. Okay, next year, B person can donate blood to O person because see here, antigen B, antibody A, O blood group person. See, in this case, see here, AB. Here, clumping occurs. Why? Statement I said that. Donor's antigen, recipient antibody should not be similar. So many students sending doubts, O positive, O negative. That is a different topic. Let me finish this. After this, I will say. How we will find O positive, O negative, A positive, A negative, B positive, B negative? It will take time. Next topic. Okay? Let me finish this. Okay, B blood group person donate blood to O person. B person. See, blood group is B. If you donate blood to O blood group person. So donor's antigen, recipient antibody, similar. Yeah. Donors, B blood group. B blood group person, if you donate blood to O person, that clump occurs. Because B blood group, donors, antigens, recipient antibody should not be similar. Here similar, so clumping occurs. Okay, next year, AB. If you donate blood, clump occurs. So statement I had given, you see that same donors, antigen, recipient antibody should not be similar. In this case, AB and A is similar. Therefore, the blood is clump. Next year, in this case also, AB, same. Donors, antigen, recipient antibody should not be similar. If similar, clump. In AB and B case also same thing happened. That's the clump. No clumping occurs. Here, no clumping because AB blood group person is universal recipient. We can take blood from any person. Okay, so AB person is equivalent blood group, O blood group, same. Clump occurs. clump occurs. Because say donor's antigen recipient antibody should not be similar, it should be dissimilar. O blood group person, see, he can donate blood to any person. He can donate blood to. He can donate blood to any person. O person is a universal donor. Can donate blood to A person. Can donate blood to B person. Can donate blood to A person. Can donate blood to O person. Because O blood group person is universal donor. Can donate blood to anybody. Reason is already know that. Okay. Here, no antigens. He can donate to B blood group person. Why? No antigens. Here antibodies. Dissimilar. Statement I said, one statement, that statement everybody found. Donor's antigen, recipient antibodies should not be similar. It should be dissimilar. See, in this case, no antigens, antibodies here, dissimilar. Okay, please donate to this person. Donor's antigen, no antigens. Recipient antibody here, dissimilar. If it is A blood group person, antigen A, antibody B. O blood group person is donating blood to A person. Donor's antigen, no antigens. Recipient antibody B, dissimilar. So that does not clump. So in last case, no clumping occurs. 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 In this case, no clumping. AB blood group person is the universal recipient. He can take blood from this person, no clumping. This person, no clumping. This person, no clumping. This person, no clumping. O blood group person is the universal donor. Therefore, he can donate blood to A person, no clumping. B person, no clumping. AB person, no clumping. O person. Okay, man. For everything, statement is one. Donor's antigen, recipient antibody should not be similar. Okay, ma? So still continuation is there. That is we will see next class. Okay, some students said doubts. Let me clarify those doubts.